So as do I shoot, who is hotter, Angela or Pam? And I'm going to essentially ask the same thing from Alpaca. Let's run this and run this. Hey everyone, my name is Venelin, and in this video I'm going to show you how you can run Alpaca in a Google Colab notebook. We're going to download weights for the LLaMA model, and then we are going to do the same thing for the Alpaca 7B model, which is the model that contains 7 billion parameters. We're going to have a look at what those models are and why you might use them. Then we're going to create somewhat of a generic framework in which you can basically give some inputs and receive some outputs with Python in the Google Colab notebook. And then we are going to ultimately create a comparison or do a comparison between the responses of ChatGPT and the Alpaca model within our Colab notebook. Let's get started. The model that we are going to have a look at today is called Alpaca. It is released by Stanford, and it is a fine-tuned version of LLaMA, which is a large language model by Meta AI. Let's have a look at the original paper. So this is the paper, LLaMA, Open and Efficient Foundation Language Models. At least at the recording of this video, the weights of this open model are not publicly accessible by Meta, but they were leaked in torrent files. You can look for those in some GitHub repos with pull requests. So the paper states that there are outperforming GPT-3 with much less parameters, which is a great achievement. And I'm going to go to the table that pretty much describes the differences or the evaluations of the different models. And as you can see, LLaMA is provided with a lot of different weights or number of parameters. And as you can see, even the smaller or the smallest model is performing very well compared to GPT-3. So this is very much a good starting point for our model Alpaca. And Alpaca is, as I already told you, a fine-tuned version of LLaMA. And it is a fine-tuned version of the smallest possible model. And it is trained with 52,000 instructions. The interesting thing about Alpaca is that it behaves similarly to TextDaVinci 003, and it is much cheaper compared to that. So already we have some very large statements or impressive statements compared to the previous models. And it seems that this model was essentially using TextDaVinci from OpenAI to generate supervised training tasks and use those instructions with the outputs to generate essentially a dataset for Alpaca and fine-tune further the LLaMA model with the instructions and the responses from OpenAI TextDaVinci. So essentially what the authors did was to try to use a small subset of instructions using the self-instruct method that is described in this paper, which I'm going to show you. So this was pretty much the original paper that OpenAI have described about the way that they were training GPT-3. And in this paper, we can see the diagram over here, which is essentially the process that OpenAI have used to generate some instructions, then take the responses, filter through those based on some heuristics, and probably try to, they were also trying to remove duplicate outputs and essentially reuse the outputs of the model as new input data, and then essentially create this loop in which they were generating those instructions and outputs. So this is pretty much the way that Alpaca model authors from Stanford used the 52,000 examples that were essentially generated by OpenAI's model. To evaluate the model, they basically took 5 students and told them to try some inputs and essentially score the outputs from both Text DaVinci and Alpaca. And it looks like that Alpaca wins 90 versus 89 comparisons. So this is a pretty good result. And it looks like that this model is very efficient, at least compared to the training of large GPT models. And you can see that they're currently estimating that you can use only $600 in order to fine-tune such a model. In this video, we're going to use the library called Alpaca LoRa, and this is Alpaca with low-rank LLaMA instruct tuning. So this model is provided also with a dataset and then with some weights for the model. Also, they are providing scripts in which we can generate and fine-tune the model itself. And in this video, I'm going to show you how you can integrate everything into a Google Colab notebook. There is also this library called DALL-E. So this is LLaMA. And this library is using Node.js in order to provide you with a very nice web interface. But this is based on Node.js, and at least in my opinion is not as good when you try to integrate those types of models in your API, for example, or your own products. So I'm going to use the Alpaca LoRa repo over here, and I'm going to show you how you can basically run this in a Google Colab notebook. Maybe you can wrap it in an API. And if you're interested, in some of the next videos, I might show you how you can actually fine-tune this model. Here I have a Google Colab notebook that is running a GPU already, and you can go to runtime, change runtime, and use a GPU right here. I'm not using anything premium, so I'm just showing you the NVIDIA SMI, and as you can see, we're using a Tesla T4, at least in this notebook. So the first thing that I'm going to do is to essentially go and clone the Alpaca LoRa repo, and I'm going to go here, get the HTTPS address, go to the Google Colab notebook and clone Alpaca LoRa, and this will go and download the repo itself. So as you can see, here we have the repo with all of the data files. Great. So next I'm going to enter the directory here of the repo. Okay, and then I'm going to check out the specific commit, at least at the point of writing this video, which is going to be, this one. So you can basically reproduce the results so far. Okay, so we're at the correct checkpoint. So now the first thing that I'm going to do is to upgrade pip. Then this repo, within it, there is this requirements text file, which essentially contains all of the libraries that we are going to need, except that I'm going to also install Torch 2.0, since this is not included into the requirements. So for that, I'm going to start with the pip install, the upgrade of it. Next, I'm going to upgrade the requirements or install them. And then I'm going to upgrade Torch to 2.0 and run this. And now that everything is complete, we can go and restart the notebook. And it is perfectly fine for this to take some time on your Google Colab notebook. So next I'm going to include some imports. I'm going to start with Torch. Then I'm going to include PEFT, and I'm going to show you why we need this. PEFT model, then the transformers library, I'm going to wrap the outputs of the model using text wrap. And from the transformers library, I'm going to import LLaMA tokenizer, LLaMA for casual language modeling, and then generation config. So essentially this will be the tokenizer that we're going to use, and these are in the main version of the transformers library so far. It is currently still unreleased. Then we have LLaMA for casual learning language modeling, and then the generation config, which is pretty standard when you're talking about generative models in the transformers library at least. And then I'm going to import a type that the generation is going to output from the utils. I'm going to import greedy search decoder only output. So this will be the data class that the model is going to output when we are running some inputs through it. So transformers utils. Let's run through all of this. So it says that it can't import this. So maybe I have a typo. So LLaMA for casual causal. Oh, sorry. Yeah, causal, not casual. All right, that was good. So next I'm going to get the device, and since we're running on CUDA enabled machine, the CUDA is available should return true. Otherwise, just in case, I'm going to say that we're running on a CPU. Pretty standard PyTorch stuff. So yeah, we're running causal language modeling, not casual. All right. So why we need all of this? If you go to the Alpaca LoRa repo, you can see that they're using PEFT, which is a Hugging Face library, and then they're using Bits and Bytes, which is a library by Tim Detmers. Sorry, man, I can't really pronounce that name, but thank you for making this library. And they're saying in here that they're using those libraries to cheaply and efficiently fine-tune the Alpaca model. So PEFT is state-of-the-art parameter-efficient tuning methods. And then they're also including here the method which Alpaca LoRa is using. And you can go a bit deeper if you want to. I haven't looked into this. And then we have 8-bit CUDA functions. So this pretty much is probably trying to reduce the weights of the Alpaca model by a lot, since even though it's the smallest possible Alpaca model, it still has 7 billion parameters. So yeah, this is pretty useful. We are going to download the weights for the tokenizer, and I'm going to start by creating a variable for it. And I'm going to take the LLaMA tokenizer, and I'm going to call the pre-trained. And in here, we are going to use LLaMA 7B for Hugging Face. So this is pretty much the weights that are provided by the LLaMA library. And they are by Decapoda Research. Man, I can't really pronounce those names. So those guys are giving us the 7 billion parameter model, and we can use this for the tokenizer. This should go and download it for us. Next, I'm going to start or continue with downloading the Alpaca. I'm going to use the same weights to download the LLaMA model for causal language modeling. yeah, pretty much the same. And here I'm going to specify that I want to load this into an 8-bit tensors, which is going to save a lot of space for us using the bits library that we've discussed. And then I'm going to specify the device map, which is going to be auto. So this should put the model on a GPU. All right, so this goes and downloads the very large model that we are going to use. And since this is downloading, I'm going to continue with the PEFT model. So essentially the PEFT model is going to be a wrapper around this original LLaMA model with the weights that we have here. So the PEFT model is going to be again pre-trained. And the first parameter, since this is the wrapper, is going to be the model. And then here we are going to use the weights from Alpaca LoRa 7B. So these are adapted versions of the original weights. And yeah, I'm going to get these from Hugging Face, of course. And next I'm going to set the type that we are going to have for the tensors, and it's going to be 16-bit floats. As you can see, even though it's only 7 billion parameters, it takes some time to download those weights. I'm going to continue with the model itself. And while this is still downloading, I'm going to essentially get through the Alpaca LoRa repo. And if you go here and open this generate script, I'm pretty much following what the original authors are doing from here. And from here, you can see this comment, unwind broken decoder research config. So these configs for the token IDs are essentially converted or fixed using the 0 for the path token ID for both the tokenizer and the model for the configs. And then we have those two token IDs, end of sequence and beginning of sequence, pointing to 1 and 2. So I'm going to take this and essentially copy it into our notebook while this is still downloading. And further, we are loading in 8-bit, so I'm not going to use this. Further, the authors of this script are putting the model into evaluation mode, and then they're using PyTorch to compile in order to speed up even further the inference time of the Alpaca model. So I'm going to do exactly the same thing. I'm going to put the model in eval mode when it's done. And then I'm going to use torch.compile model. There is a very specific format that you need to use in order to create those templates for the input for Alpaca models. And within the original Stanford Alpaca model, you can see that they're providing the data, and they're also providing the template itself that you can use. And we're going to use the one with the empty input field. So the template essentially says below is an instruction that describes the task, write a response that appropriately completes the request. So we have the instruction with a markdown format, I would imagine, and then a response. So I'm going to essentially get this, which is again the simpler template. And I'm going to create a variable called prompt template in which I'm going to essentially paste in the prompt. And we're going to replace this based on our needs. So this is the prompt template. And here I'm going to replace this with instruction. Here is the template, exactly the same thing. And I'm going to create a function called create prompt, which takes an instruction, which is a string, and outputs the prompt. And within this, I'm going to use the prompt template. And I'm going to replace this part, the instruction, with the brackets, the square brackets. And I'm going to replace this part with the instruction that is given within the function parameter. Pretty simple. Let's try it out. I'm going to print the prompt. And let's say that the first prompt is going to be what is the meaning of life. Let's see the format that we are going to use to the Alpaca model. So pretty much what we expect. The instruction is right here, as you can see. So this is working very well. So let's continue with generating the responses from Alpaca. And I'm going to do at first something very basic. We are going to just write a script within a Google Colab cell. And then I'm going to write some functions that we are going to reuse, and probably you can reuse for yourself. I'm going to give you a bit more modular approach to asking Alpaca and receiving outputs. So the first thing that we need to do here is to use the tokenizer. So for that, I need to create a prompt, and I'm going to take this, create a prompt from it. And for the tokenizer, it's pretty simple. I'm going to give it the prompt, and I want to return tensors, which are in the PyTorch format. And this is going to be the encoding from it. So for the encoding, yeah, we have keys, attention mask, etc. Let's see the keys. Pretty standard Hugging Face stuff. We have the input IDs and the attention mask. And in this example, we are just going to use the input IDs. So I'm going to take this and put them on the device that we are going to use. And if you print this, this should be a tensor that is on CUDA, so it appears to be working as expected. Next, I'm going to create a generation config, and this is going to be some parameters that we are going to specify of how Alpaca is going to generate the model. So in here, I'm going to specify the top percentage of the tokens that we're going to use from a probability standpoint. Then I'm going to take a look at the temperature, and then we're going to add a slight penalty for repetition. So this generation config is standard for pretty much every generation model from Transformers library. Temperature, a small value. These are some numbers that I've pretty much taken from the generate script from the Alpaca LoRa, except for the repetition penalty. I just like to increase that a bit. So this is the config. Yep, everything works as expected. And then I'm going to do the inference itself within a torch inference mode block. And the generation or the output is going to be the result of model.generate. I'm going to pass in the input IDs, the generation config, and I want this to be a return, or the response I want to be in a data class, which we already imported. And I want to have a look at the scores, and I want the maximum number of new tokens, or the generated tokens, is to be 256. So let's run this. Let's have a look at the output. And as you can see, we have decoder, greedy search decoder only output. We have sequences and we have the scores for each, essentially for each token. And you might have to have a look at those. So I'm going to take the sequences and have a look at how many of those do we have. It should be just one. All right. So for this sequence, which is essentially a tensor, I'm going to call the tokenizer again, and I'm going to decode it. I'm going to decode the output sequence, and you can see that the result contains the original instruction along with the response. So you can see below is an instruction. This is essentially the template along with the instruction that we give it. And this is the response. The meaning of life is to find purpose and meaning in one's own existence, as well to contribute positively to the world around them. So very positive outlook from Alpaca. I like that very much. So how we can essentially get just the response? Well, again, in this generate script, I found this line. So we are splitting based on the response and stripping the output from that. So I'm going to do that. So the decoded response is going to be this. And when I do the split based on the markdown response, take the first result and strip it, we should get just the response, hopefully. Yeah, the meaning of life is to find purpose. Great. So now we have the Alpaca model running in a Google Colab notebook. Let's wrap it up in some easy to use functions and try to compare it with ChatGPT. What I'm going to do next is define some functions that we are going to essentially copy and paste the code from here in order to make this a bit more easy to use. So let's define generate a response, which takes a prompt and a model and outputs greedy search. Let's see if the autocomplete is smart enough for this. It looks like it is. So I'm going to take this part and then I'm going to take the input IDs, put it here, get the generation config as well, and then the inference mode, essentially copy and paste everything here within the generate response and return the result from here. So this is the generate response function. Next, I'm going to do the formatting that we did over here. So I'm going to write another function called format response. And this should take the response from the model, which is this data class. And this should just return a string. So next I'm going to get the decoded output from here. Let me just rename this to decoded output. Then I'm going to take the splitting in order to get just the response. And I'm going to just use the text wrap library here, which we already imported. And this will wrap the response in case that the response is much longer compared to this. So we might get a better output. So this is the format response. And then I'm going to create the last function that is going to be called ask Alpaca. And this is going to be essentially a wrapper around the functions that we have thus far. And the model is going to be path model. And we're going to input the default model that we have. I'm going to use the create prompt function that we already created. Then take the response. Pass in the model. And then I'm going to print the format response result with the response. So let's try this function, and I'm going to get just the input from here, and I'm going to call with this prompt ask Alpaca. Let's see if everything is running. So you might want to go and check some of the parameters in here. You might want to give them some in some sort of a config, or maybe as default parameters in here. This is of course not perfect, but you might have to play it out the way that you want it to wrap it. And this is the text wrapped response. You can see that it is much nicely formatted compared to what we had previously, and it appears that it is working. I have a couple of prompts, and we are going to try those prompts in both ChatGPT and the Alpaca model that we are already using. And we are going to have a look at how each of those models is performing based on the outputs. I have ChatGPT and Alpaca models right here, but I've made a mistake over here. I've just reused the output. So I'm going to pass in the response and essentially rerun everything. While this is computing, I'm going to run this through ChatGPT and compare the results. So it says that the meaning of life is a philosophical and existential question. Humans for centuries are being puzzled by it. It looks like that it's fulfillment through personality and purpose. Okay, so it sounds all right. The meaning of life, at least from Alpaca model, response is much more succinct. The meaning of life is to find purpose and fulfillment in one's own life, as well as to contribute positively to the lives of others. So I like this summary very much compared to what ChatGPT is currently giving us. Probably we might do some prompt engineering or try to reduce the number of output tokens, and we might get similar result. Of course, this is much more expanded version, but Alpaca, at least for this one, is winning it for me. So let's try something a bit more interesting. I'm going to get this, and I would essentially ask the same thing, but I'm going to give a personality, and the personality is going to be Dwight K. Schrute. So as Dwight K. Schrute, what is the meaning of life? I'm asking him with the Alpaca model. And I'm going to ask the same thing from ChatGPT. So the meaning of life is to find happiness and fulfillment in whatever you do, no matter about how big or small it might be. All right, so again, the response from ChatGPT is much more expanded version of this. This is very succinct. I like it. ChatGPT talks about proud patriots, and it looks all right. But yeah, again, I much more like the succinct version over here. Next prompt, but this is still great, of course. The next version of this prompt is going to be a bit larger, so I'm going to paste it in here. So you're Dwight Schrute, and I would like ChatGPT and Alpaca to make a decision. So again, we are acting as do I should, and the dilemma here is, do I have a typo? I'm not sure. Leave your office job and be just a beet farmer, or be a paper salesman but leave your farm. And I would like to act as do I should and make the decision from here and to explain why. All right, so we're giving this to ChatGPT, and let's do the same thing for Alpaca. I'm going to copy this and give it here. So as do I should, I would approach the dilemma by analyzing the situation from all angles and making a practical. Okay. Ultimately, I would have to weigh the pros and cons. In the end, the decision would come down to what is the best for happiness and long-term success. So it looks like that it's not making the decision at all. But if we are talking about Alpaca, I would choose to stay as a paper salesman, even though I'm also a beet farmer. The reason for this is because I enjoy being able to interact with people on a daily basis and having a steady income. Being a beet farmer requires more time and effort than selling papers. Okay, so it would not be feasible for me to do both jobs at once. So again, much more succinct. But ChatGPT is weighting the pros and cons. Again, very different responses. All right, so next I'm going to ask for some investment or financial advice from both ChatGPT and Alpaca. So I'm going to get another prompt that I've already prepared. So again, we are acting as do I should, and we would like it to write an investment plan with allocation percentages for $10,000. Oh, so I have a typo. And yeah, I would again do the same thing with Alpaca. Let's see what kind of a response do we get. So as do I should, practical conservative mindset, which is all right. So we are requiring it to not go bust. My goal would be to return on my investment without taking unnecessary risks. Sounds good. High yield savings account, 40%. Okay. Index funds. Okay, so 80% within high yield savings account and index funds. Individual stocks. So I would research the companies thoroughly. So it will do due diligence and do some financial healthy investment, growth potential in industry trends. Crypto, 5%. Okay, interesting. An emergency fund. So you would leave an emergency fund just in case. Okay, so it sounds very good. So for the investment plan from Alpaca, low risk, high return mutual funds. 25% to a high risk, high return stock portfolio. So it's much more risky compared to ChatGPT. 25% bond portfolio. Okay. And then a real estate portfolio. So the results are quite different. Alpaca is talking about real estate and much more aggressive within the approach with the allocations, I would say, while Dwight is 80% in very low risks, and then he is also having a 5% something that is considered cryptocurrency a high risk investment. So the results are pretty different, and I like actually both of them. So the final question that I'm going to ask, and probably the most important one, is going to be this. Let me just copy the prompt. So as Dwight Schrute, who is hotter, Angela or Pam? And I'm going to essentially ask the same thing from Alpaca. Let's run this and run this. I believe that both Angela and Pam Okay, so it's not making the decision at all. I think so. Alpaca, I think both Angela and Pam are equally attractive, but I would have to give the edge to Pam because she has a more classic beauty. So Alpaca is definitely deciding that Pam is hotter. In this video, I've shown you how you can use the Alpaca LoRa repo in order to get Alpaca running in a Google Colab notebook. We've seen how we can use the tokenizer, download some weights, and using the Torch 2.0, we can essentially speed up the inference time of this model. I've shown you how you can build somewhat generic way to ask Alpaca for some responses. We've seen the template that you can use also. And there will be a complete text tutorial, which includes, of course, the Google Colab notebook within this video. Please like, share, and subscribe. And guys, if you want to have me show you how you can fine-tune this Alpaca model based on some of your own data, for example, I'm going to make another video, but only if you like it or share this video and leave a comment down below that you want to have a look at the fine-tuning code from that. Thanks for watching, guys. Bye.